Students will discuss today question bank. Okay. So 2.5 modules we have to discuss. Module 1, electrochemistry and corrosion. Module 2, water technology. Module 3, engineering materials. We are going to discuss polymers. Hello, students.
Yes, ma'am.
Yes. You started preparation, huh?
Yes, ma'am.
Everybody.
Yes, ma'am.
First module completed or second?
First module completed.
Completed, huh? Okay. So you know the question paper pattern, you know, okay. So according to that, you can plan, you can prepare. So in question bank, we are having 3 parts, ma. So part A, short answer questions. Part B, long answer questions. Part C, problem solving and critical thinking questions. So question paper pattern already, you know, we are having, you will get 5 questions, okay, from each question. A, B will be there, okay. So A question you will get theoretical, okay, ma, theoretical from part B, and C question means the other B question you will get from part C. You will get analytical question or you will get a problematic, okay. So you have to prepare thoroughly part B and part C. So from first module you will get for 10 marks, second module 10 marks, and from third module you will get for 5 marks. Okay. So we'll discuss part A, part B, part C. Okay. Hello, students.
Yes, ma'am.
Yes, ma'am.
See, whenever so whatever the question I am reading and discussing, so you have to tell the answers. Okay, now then only I can continue. Simply reading the questions waste. Clear, everybody? Okay.
Yes, ma'am.
Okay. Define the terms electrochemical and electrolytic cell. So what is electrochemical cell?
Which converts chemical energy into electrical energy.
Chemical energy to electrical energy. Okay, what is electrolytic cell?
Which converts electrical energy into chemical energy, ma'am.
Electrical energy to chemical energy. And what is the function of salt bridge, ma'am?
Which maintain electrical neutrality.
Okay. So what is EMF definition? EMF definition.
Maximum potential difference between 2 electrodes.
Okay. So what is the, how to represent galvanic cell? Representation you type. Galvanic cell representation you type.
Anode and cathode separated by salt bridge.
Anode and cathode separated by a salt bridge or connected. Hello? How you are representing a galvanic cell?
Ma'am, Zn SO4 double dash Cu SO4 dash Cu.
Okay. So first we will write anode on left side, cathode on right side. So anode we will write electrode, then electrolyte. So cathode, what we are writing, how we are, means we are writing on right hand side electrode, right hand side we are writing. So we will write electrolyte and electrode. So that two are connected with the salt bridge. So representing here with the double vertical line. So first we will write electrode, electrolyte, left side. Then right side we will write electrolyte, electrode. So that two are connected with the salt bridge. So representing with a double vertical line. Now students, what is battery?
Connection of cells in series.
Combination of cells in series. Classification of batteries. Classification. Batteries are
Second.
primary batteries and secondary batteries. Okay. Differentiate between primary and secondary cells. Tell 2 points you tell me. Primary batteries and secondary batteries.
Primary non-rechargeable.
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 Secondary is rechargeable.
Secondary will be
Irreversible.
rechargeable.
Irreversible.
Primary, which is irreversible?
Primary.
The reaction in primary
Secondary?
cell is
Secondary will be
Irreversible. Reversible.
Charging and
okay.
discharging.
Okay. So in primary only what type of reaction takes place in primary?
Reversible.
Huh? In primary, discharging or charging?
Discharging.
Discharging reaction. Okay. So in secondary,
Charging,
Charging
discharging,
and
and charging.
discharging and charging. Okay. Now explain discharging and charging reactions of lead acid battery. So what? Now tell me, students, in lead acid battery. So what is anode? What is cathode? What is electrolyte? In lead acid battery, what is anode? What is cathode? What is electrolyte?
Lead is the anode.
Huh? You can see and you can tell. What is anode in lead acid battery?
Lead, ma'am.
Lead. Cathode.
Lead oxide.
Lead oxide. Electrolyte.
Lead
Electrolyte.
sulfate.
Dilute H2SO4. Dilute
H2SO4.
H2SO4. So what is the question here is, explain the discharging and the charging reactions of a lead acid battery. Okay. So you have to write only discharging reaction and charging reaction. So discharging means what, ma? Students, what is discharging?
Chemical energy converted to electrical energy.
Chemical energy converts into electrical energy, means we are using the battery. Okay, so the reactants, it will be converting into products. So we have taken anode is lead, cathode is lead dioxide, and electrolyte is dilute H2SO4. So here what happens at anode? So lead, it is undergoing what type of reaction, if it loses electrons?
Discharge.
Oxidation.
Oxidation reaction. Tell me, what is oxidation reaction? Hello,
Just electrons.
Reduction of electrons, ma'am.
Huh? What is oxidation reaction?
Which loses electrons.
Losing of electrons, ma'am.
Losing of electrons. So lead will lose electrons. Okay, undergoing oxidation reaction. Okay, so this Pb2 plus ions, it will react with sulfate ions and will get lead sulfate at anode. Lead sulfate product at anode, and at cathode lead dioxide in presence of electrolyte H2SO4. It will gain electrons. It will take electrons and reduce to PbSO4 and H2O. So this lead sulfate, it is formed like a precipitate at cathode. Okay. So what are the products we got during discharging reaction? Students?
Lead sulfate and
Lead sulfate product we got at both the electrodes, anode and cathode. So net reaction we can write lead plus lead dioxide plus 4H plus 2SO4 2 minus gives rise to 2 PbSO4 plus 2H2O plus energy. So chemical energy converted into electrical energy. Reactants are converted into products during discharging reaction. So during charging reaction, so we have to supply electrical energy. Electrical energy converts into chemical energy. So we will use here electrical energy so that the products will be converted into reactants. The products will be converted into reactants. Again, we can go for discharging reaction. So net reaction here is during charging is 2 PbSO4 plus 2H2O plus supplying energy. So gives rise to lead plus lead dioxide plus we are getting 4H plus 2SO4 2 minus. So these are the reactants. Okay. So anode, cathode and electrolyte. So these reactions you have to write, explain discharging and charging reactions of lead acid battery. Write advantages and applications of lithium-ion battery. So advantages and applications you have to write. Okay. I gave here. It will have low self-discharge, low maintenance, okay, na? Low shelf life, high energy density. You write this as these advantages. Low shelf life, long shelf life advantages. We can use more period of time. Okay, so low maintenance, we can maintain easily. Low self-discharge. Okay, high energy density. And applications also you have to write laptops, cellular phones, mobile phones, electric vehicles. So these applications you write. So next What is single electrode potential? So students, we discussed in the first module about electrode potential. Okay, when you are dipping any electrode in electrolytic solution, okay, so it will undergo either oxidation reaction or reduction reaction. Now students, tell me what is single electrode potential. I'm not asking standard electrode potential. Okay, na? Now tell me what is electrode potential? Definition. Hello students. What is electrode potential? Hello? Hello students, what is electrode potential?
Potential difference between
Electrolytic solution and electrode.
Electrode.
electrolytic solution and electrode.
Potential difference between electrode and electrolytic solution. Okay. So how to determine the electrode potential of zinc? You want to know electrode potential of zinc. How you will determine, students? How you will determine?
Should connect with hydrogen electrode.
Now we should connect.
Will connect with the, see this is zinc electrode, okay, na, in zinc sulfate. You have to connect to the
Standard hydrogen.
standard hydrogen electrode. You have to connect to the standard hydrogen electrode. So that you will connect to the voltmeter. That is a hydrogen electrode and zinc electrode. You will connect to the voltmeter. And these two solutions, zinc sulfate and HCl, you will connect with the salt bridge. Okay. So here, what happens at zinc electrode, ma? What is the reaction, students? Students, what is the reaction at zinc? Hello.
Oxidation.
Zinc,
Oxidation reaction. Oxidation reaction. So zinc, it is losing electrons. Ma. So what is the reaction at the cathode hydrogen electrode?
Reduction, ma'am.
Reduction reactions. The electrons are
Addition
taken,
of electrons.
not copper. Electrons are taken by H plus ions and reduced to the H2. Okay. So now here zinc electrode act as a, hello students,
Anode.
anode. Hydrogen electrode act as a
Cathode.
cathode. Okay, one formula is there, Telma. Students, one formula. E cell is equal to
E cathode minus E anode, ma'am.
E cathode minus E
E
anode.
anode.
Anode is zinc here. Cathode is hydrogen electrode. Now tell me standard hydrogen electrode potential.
0.
0. So E cell is equal to 0 minus, and we will write here 0 minus 0.76. So then you can calculate E cell. Yes or no?
Yes, ma'am.
Okay. So how to determine electrode potential of zinc means, so that you have to take the diagram, okay, with SHE, then you can write. Okay. What is electrochemical series? Students, what is electrochemical series? Electrochemical series, you know the values also, some for some electrodes. What is electrochemical series, ma? How we are arranging? Elements are arranged
Standard reduction
are arranged
potential.
Electrode potential.
in the increasing order of standard
Reduction.
Electrode potential.
reduction electrode potentials. Elements are arranged in the increasing order of standard reduction electrode potential. So that definition you have to write. And applications, my any two applications, tell me with the help of this list. Students, any two applications, ma? Hello, students. See, when you got this list, you know the potentials here. What you can predict here?
Feasibility.
We can calculate the E cell.
Reduce or oxidize.
You can calculate the E cell. Okay, no problem. Next.
Oxidizing
Can
and
know which is anode and which is cathode.
You can know which is anode and which is cathode. Which electrode will act as anode, which electrode will act as cathode with respect to the hydrogen electrode. Okay, na? And you can easily find out here which metals easily it will undergo corrosion. Okay, which metals are more active and which metals are less active, which metals have higher reduction potential and which metals have lower reduction potential. So you can write applications. So next month, derived Nernst equation you have to learn. Okay, na? You have to learn, you have to write. Next, describe the construction of calomel electrode. Students, how to construct calomel electrode? We'll take a long glass tube. Tell me
Pure
When I take a long
mercury.
glass tube,
what we will fill in the long glass tube.
mercury.
Bottom mercury.
Bottom
Mercurium.
mercury.
Mercurous chloride.
Then mercurous chloride paste.
Then KCl.
Then
KCl
you
solution.
will you will KCl.
The
Then
platinum rod. Wire.
how to insert the platinum
wire.
Salt
wire?
bridge.
Okay.
And
How
salt
to
bridge.
insert? There are two inlets are there. Tell me.
First
One
inlet is
inlet.
KCl solution.
We will take KCl solution. Okay.
Other
Other
is salt
inlet
bridge.
salt
Salt
bridge.
bridge.
Connecting to salt bridge. Okay. So you have to learn the diagram. Okay, na? So for galvanic cell, you have to learn the diagram. For calomel electrode, you have to learn the diagram. Okay, na? Wherever the diagrams are there, ma. Okay, for batteries, everywhere in corrosion or electrochemistry, water. So wherever the diagrams are there, you have to learn the diagram. You have to draw neatly. Okay. Students, what is corrosion? What is corrosion, ma?
Rusting of metals, ma'am.
Rusting of metals. When metal will undergo
Oxidation.
Oxidation reaction.
when it will undergo oxidation reaction.
Oxidation on the surface.
When oxidation of the metal takes place, nothing but corrosion. When
When it's
Exposed to
exposed to
when metal is exposed to the
Moisture.
moisture conditions, when metal is exposed to the chemical or electrochemical environment, electrochemical attack of okay, in the presence of environment, we can take either absence of moisture or presence of moisture. So any two are disadvantages, ma? When metal is undergoing corrosion,
metal loses strength.
metal loses strength, metal loses properties like
Lifespan.
lifespan decreases. Okay. Means we can't use for more period of time. Efficiency of the machine will be decreasing. Okay.
Metallic properties.
Decreasing metallic properties like electrical conductivity, malleability, ductility. Okay. Now, what is Pilling Betworth rule, ma? The scientist, he explained in different way about porous and non-porous layer on the surface of the metals. Tell me, what is Pilling Betworth rule? Hello, students, what is Pilling Betworth rule? If the volume of
oxide found by volume of metal consumed.
metal oxide is if the volume of metal oxide formed is if the volume of the metal oxide is greater than, hello students,
Volume of metal consumed.
if the volume of the metal oxide is greater than volume of the metal, then that metal will have
No
that
corrosion.
metal will have which type of layer? That metal will have porous or non-porous layer?
Porous.
You are not listening, students. If the volume of the metal oxide is greater than volume of the metal, that metal will have porous layer or non-porous layer?
Non-porous, ma'am.
Non-porous layer. If the volume of the metal oxide is lesser than the volume of the metal,
Porous, ma'am.
porous layer. Okay, so non-protective layer. Okay, that metal will undergo corrosion. Students, what is liquid metal corrosion? Here I gave specific volume ratio, 3 examples, ma. Nickel, chromium, tungsten. Tungsten will have higher specific volume.
3.6.
3.6. 1.6 is nickel.
Nickel.
Chromium is 2.
2.
So higher the specific volume ratio, lesser will be
Porous.
higher the specific volume ratio, there will be corrosion in that metal.
Yes, ma'am.
No.
Inversely
No, ma'am.
proportional, ma'am.
Less corrosion,
Ma'am,
ma'am.
lower corrosion.
Less corrosion. If the specific volume ratio is less,
More
No
corrosion, ma'am.
more corrosion will be there. Okay. Students, what is liquid metal corrosion? How the corrosion takes place in these conditions when we are taking two metals, one is in liquid, one is solid metal. Students, you are taking in solid pipe molten metal, ma. How the corrosion takes place? I explained there are two ways it will be possibilities there.
Liquid metal dissolved by lithium metal something.
Liquid metal is dissolved by
Lithium metal. An example is said, ma'am.
solid metal is dissolved by liquid metal, or liquid metal it will penetrate
Penetrate into solid metal.
solid metal. Okay. What is dry and wet corrosion? Tell one difference or two difference. Dry, you know, dry corrosion, you know, wet corrosion, you know, both are different. Students.
Without moisture, dry.
Dry corrosion means corrosion in metals takes place in absence of moisture. Wet corrosion?
In presence of moisture.
In
Oxidation.
presence of moisture. Any other difference? Both? Any other difference? Where will be uniform corrosion? Hello, students. In which type uniform corrosion in metal takes place? Dry or wet?
Wet.
Uniform corrosion.
Dry.
Dry corrosion. So uniform corrosion takes place in metals. In wet
Loss of
corrosion.
electrons. Okay, yes.
In wet corrosion.
Gain of electrons, ma'am.
Non-uniform.
Non-uniform, ma'am.
Non-uniform corrosion. Students, what is cathodic protection? How you are protecting the base metal? What is cathodic protection? You want to protect a base metal, protective metal. How? Cathodic protection. Two
And we are
types.
connecting metal which is more active than the
More active than the
base metal.
more active than the base metal.
Base metal.
Okay. So we will connect more active metal, okay, to the base metal, which is more active than the base metal. So that is cathodic protection. So that the base metal will become here. Students.
Cathodically protected.
Cathode. It will act as cathode.
Cathode.
And the other metal
Anode.
will act as a anode. So here given question is students, here given question is sacrificial anodic protection method. So in sacrificial anodic protection method, so we will take more anodic metals. So we will connect to the base metal. Okay. So to the base metal, we will connect more anodic metal. So that more anodic metal will undergo corrosion. It will undergo oxidation. Okay. It will act as sacrificial anode. It will sacrifice itself and protecting the base metal. Okay. Students, what is impressed current cathodic protection method? Impressed. This is different. Impressed current cathodic protection method. What we are using here, impressed current cathodic protection means what? We are using
External power source.
electrical power source. Okay, external source we will use, direct current source, and we will protect the base metals. Students, what are the applications of galvanizing? Galvanizing applications, uses. Any 2 points? Uses of galvanizing. Buckets. Hello.
Machine parts.
Prevents from rusting, ma'am.
What uses you tell me? Okay, preventing
Applying
rusting.
for machines, ma'am.
Huh?
Applying for machines.
Applying for machines. Some applications I gave, ma. Buckets, tubes, pipes, bolts, screws,
Fires, tanks.
wires, all that. Not pans.
Tanks.
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 Okay. Students, what is hot dipping? Hot dipping. So this only we will apply in galvanizing process. Tell me what is hot dipping?
I'm dipping the base metal in molten
Dipping the base
Bath
metal.
of molten zinc, ma'am.
metal.
We are dipping the base metal in molten metal. Yes or no? Molten coating metal.
Molten zinc.
Molten zinc. Okay. So the molten coating metal that should have low melting point to the base metal. Yes or no?
Yes,
Yes,
ma'am.
ma'am.
Okay. So what is the importance of tinning, ma? It is non-toxic. Tin is non-toxic. What is the importance where we are using? Students, tin is non-toxic in nature. Where we use this
Storing food items.
storing food and packing food. Okay, ma. Okay, you write that here. Okay, applications. Students, what is electroplating? The deposition.
For deposition of metal.
The deposition of
on the
coating
surface.
Coating of metal, ma'am.
coating
metal.
metal on the surface of
Base metal.
Base metal.
base metal
Base
by the
metal.
process of
Electrolysis.
by the process of electrolysis by the process
Electrode
of,
deposition process.
what is that? My electrolysis process means what? What is process? What is the process of electrolysis, students?
Process.
Electrical energy we supply, yes or no?
Yes, ma'am.
Tell
Yes,
me.
ma'am.
Electrical energy converts into
Chemical energy.
chemical energy. So there will be decomposition of chemical substances taking place. For example, we will take here copper sulfate, and we are taking one iron key, so that when we are supplying electrical energy, decomposition of copper sulfate is taking place into Cu2 plus ion, sulfate ion. So that sulfate Cu2 plus ions, it will move towards the negative electrode. That is, we are connecting this iron key to the negative pole of the battery. Yes or no?
Yes, ma'am.
And this will undergo reduction reaction. Okay, so this copper atoms, it will be deposited, okay, on the surface of the key, iron key. Okay, so this is electroplating process. Now students, part B ma long answer questions. Okay na? So this you prepare completely. Okay. How many are there? 9. Wait, 15, 20 are there. Part C. Part C 4, 7, 10. Okay. Part B. This PPT I will send you. Okay na? Okay. Students, first question in part B, long answer questions. What is galvanic cell? Explain the construction of galvanic cell with the electrode reactions. Students, what is galvanic cell? It is a device. Students, what is galvanic cell, ma? It is a device which converts
Chemical energy.
chemical energy to electrical energy.
energy.
Construction you have to write. So construction you know already. We'll take zinc electrode in zinc sulfate.
2 half cells.
Copper electrode, copper sulfate. We'll connect 2 electrodes to the voltmeter. 2 electrolytic solutions we are connecting with the salt bridge. Okay, construction you have to write. And electrode reactions, that is at anode what reaction, cathode what reaction. Okay, so you have to write construction, working of galvanic cell, function of salt bridge. You write one line, function of salt bridge. What is the function of salt bridge, ma? It
To maintain the flow of
electrical neutrality in both the solutions, electrolytic solutions, and representation of galvanic cell, and what is EMF. So you write this completely, you write. Okay, na? Explain. Now compare between cell battery. Students, what is cell? Galvanic cell. What is a cell, ma?
combination of an anode and
Combination of
Combination
batteries,
of
ma'am.
anode and cathode. Battery means
Combination of cells.
combination
in
of
series.
cells. Okay, in
In
series.
series.
Classification of batteries already you know that you have to write, ma, primary and secondary batteries,
Secondary.
and you have to explain. Okay, some points you have to write. Now explain the construction and working of lead acid battery. So construction you have to write, ma. We will take 6 cells. 1, 2, 3, 4, 5, 6
12
cells
volts.
connected in series, ma. Each cell, so you write anode lead, cathode lead dioxide, separated with the stripes of wood. So all the 6 cells we are inserting in dilute H2SO4. Okay, construction you have to write. Then reactions completely you have to explain. Discharging and charging reactions. See this one. Discharging reaction, charging reaction. Okay. Write discharging, charging reactions and limitations of lead acid battery. Students, what is the limitation, ma? We are using acid, ma. What is the limitation? Hello students. We are using a dilute H2SO4. One limitation is there. Sometimes acid fumes, it evolves surrounding the battery. What happens to that battery if the fumes come out? Hello, students. Hello.
Didn't
If the,
remember.
if the fumes come out of the battery, surrounding the battery will undergo
Corrosion.
corrosion. The battery will undergo corrosion.
Corrosion.
So that to avoid this, we will use sealed cells. Okay, na?
Yes, ma'am.
Okay. Next, compare primary and secondary cells. You write points, ma. Learn perfectly. Okay, na? These points you have to write. Okay, this one. Compare primary and secondary cells. Explain the construction of lithium-ion battery with relevant reactions. So this also simple, ma. We will take anode, cathode, electrolyte. Anode in lithium-ion battery. So students, what we will take in anode? What will take anode, ma? Lithium-ion battery.
Graphite.
Graphite will take. Cathode? Cathode, what we will take?
Lithium.
Lithium cobalt oxide. Lithium cobalt oxide. Electrolyte, we will take lithium salts, ma. Lithium tetrafluoroborate. Lithium tetrafluoroborate will take and we'll go for construction. Okay, we'll take anode, cathode, and we'll dip in the electrolyte and we'll connect to the voltmeter. Now students, here, this is the discharging reaction. Okay, you have to write discharging reaction. So here what happens means, lithium, it will undergo oxidation reaction, losing electrons. And this lithium ion, during discharging reaction, it flows from anode to cathode. Anode to cathode. Okay, and electrons are gained by this cathode and reduced to the lithium cobalt oxide. So this is the discharging reaction. Whereas charging reaction will be, you can keep arrow mark this side. Okay, na, left side. Discharging reaction. Now students, tell me, during charging reaction, the lithium ions flows from anode to cathode or cathode to anode?
Cathode to anode.
Cathode to anode. During discharging time,
Anode
during
to
discharging time, the lithium ion moves from anode to
Cathode.
cathode. Anode to cathode. Flow of electrons from anode to cathode during discharging. Yes or no? Hello students.
Yes, ma'am.
The electrons flows from anode to cathode, and also lithium ion, it is moving from anode to cathode during discharging reaction. So now next question, part B. Explain the construction and working principle of dry cell with the reactions. Now tell me, what is anode, cathode and electrolyte in dry cell? Hello students.
Anode is zinc, ma'am.
Anode is zinc. Cathode?
Graphite.
Graphite. Electrolyte? Cathode is graphite. Electrolyte?
MnO2.
MnO2.
Starch.
NH4Cl, ZnCl2 plus starch. Okay, what they asked in the question, you see here. Explain the construction. First, you have to explain the construction. We are taking zinc as a container. We are taking anode. Then we insert a carbon rod in the center position. Okay, and then we will fill surrounding that carbon rod. We are filling with the electrolyte. So you write construction first. Then comes to the, you have to write reactions, anode, cathode, electrolyte, and net reaction. Okay, na? Anode, what happens, students? Anode, zinc. What is the reaction?
Losing
What is
electrons.
It losing
Oxidation.
electrons, oxidation reaction, loss of electrons. So at cathode, so
Reduction.
here gaining of electrons undergoes reduction in presence of MnO2, ammonium chloride, zinc chloride. What is formed here? Complex dichloro, diamine, zinc plus Mn2O3 plus chloride ions plus H2O. You write net reaction. Okay, na? So Zn plus 2NH4Cl plus 2MnO2 gives rise to Mn2O3 plus complex formation, dichloro, diamine, zinc plus H2O. So what is the EMF of the cell?
1.5 volts.
Lead acid cell,
2 volts.
lead acid battery,
12 volts.
12 volts. Primary cell, this dry cell,
1.5.
1.5. Okay. So here dry dry cell is we can go for charging reaction, ma. It can be reversed or not.
No, ma'am.
No,
No, ma'am.
it
Complex
is
number.
irreversible. It is irreversible. Reaction is taking place. It is called a primary cell. Okay. Why it is called dry cell means because we are taking here not a liquid medium electrolyte. We are taking a paste. So next,
Equation.
what is the question, ma? Okay, dry cell with reactions you write, okay? Derived Nernst equation. Everybody learn the Nernst equation completely, okay? Okay, now students.
Yes, ma'am.
Learn completely, okay? Now, what is electrochemical series? Already you told. Explain the electrochemical series with its applications. 5 applications I have given you, ma. So that applications you have to learn and write, okay? So what is reference electrode, ma?
We can find the electrode of single electrode.
What is reference electrode? When that electrode is used as a reference, ma. Reference electrode, tell me. What is reference electrode? Standard hydrogen electrode is primary reference electrode. Now tell me, what is reference electrode? The electrode whose potential is
Known.
Is known.
The electrode whose potential is known. Okay,
To find the others.
to find the electrode potential of
Another.
another electrode is known as reference electrode. You have to write that here. Understood? Okay, ma. What are reference electrodes means? You write. Describe the construction of Galvanic electrode, and that you write, ma. And potential values you write, ma. Okay. How the potential of Galvanic electrode vary with the concentration of KCl. If you are taking concentration of KCl is lesser, like a 0.1, electrode potential more or less? 3 values are there.
More, ma'am.
More. What is the potential? Remember, value?
0.33 something at once.
0.33? 0.33? 0.1 normal KCl, tell me value.
0.33. 35.
Okay. Now 1.0 normal KCl, tell me value.
0.2510.
25 got. No. 0.28. 2810. Now saturated KCl solution, tell me electrode potential. 0.24 double.
22.
Okay. Students, what is standard electrode potential?
And the electrode potential, the potential between the electrode and its
Electrolyte. Tell me that standard conditions.
At
You tell me.
293 K and
293.
1 M.
Not 293.
273.
297.
298.
In temperature.
25 degrees Celsius.
25 degrees
290.
Celsius.
25 degrees centigrade. Tell me. Electrolyte concentration.
0.1.
1 molar, ma'am.
1 molar. Okay. 1 molar concentration of electrolyte at 25 degrees centigrade. So that are the conditions at 1 atmospheric pressure in hydrogen electrode. So if that are the conditions we are taking, okay. So the potential difference between electrode and electrolyte, okay, taking concentration 1 molar at 25 degrees centigrade is known as standard electrode potential. Now here, describe the construction of standard hydrogen electrode. Students, you know how to construct a hydrogen electrode? Hello, what we are taking in the beaker?
Hydrochloric acid.
Hydrochloric acid. Then here, what we are taking here?
Platinum
layer at the bottom.
Platinum electrode.
Platinum foil. Then we are covering with the
Glass
glass tube. Okay, what we are allowing, one inlet is there.
Hydrogen gas.
We are passing hydrogen
Yes, ma'am.
gas. Okay, so at 1 atmospheric pressure. So this is the construction of standard hydrogen electrode that you have to write. And electrode reaction, you write, students, this standard hydrogen electrode. So this may act as anode or cathode depending on the other electrode you are connecting. Okay. Hello.
Yes, ma'am.
You write that reactions. Okay. So this is the 9th question. Ma. So this is construction, Galvanic electrode. Now 10th one, you know already this. Okay. What is electrochemical cell? Explain the construction and functioning of Daniel cell. Same you write galvanic cell here. Okay. What is oxidation corrosion? And how does it takes place? Describe the mechanism of oxidation corrosion. This you have to write in dry corrosion. We discussed first oxidation corrosion, no? Corrosion by oxygen. That you have to explain with the diagram. Okay. Students, what is oxidation corrosion? Hello? You have to tell what is oxidation corrosion. Corrosion in metals takes place in presence of
Moisture.
Three types are there, ma. Dry corrosion, corrosion by oxygen, corrosion by other gases, not oxygen, other gases like H2S or N2 or other gases. Third one is liquid metal corrosion. Now tell me what is oxidation corrosion. Corrosion in metal takes
Presence of
place.
oxygen.
Metal plus
Presence of
oxygen.
Presence of
Oxygen.
oxygen. Okay. So you have to write mechanism of oxidation corrosion with the diagram. So we discussed with the diagram. Anybody remember? Formation of metal oxide on the surface of the metal.
Yes, ma'am.
When metal is exposed to the atmosphere in presence of oxygen. So this metal will undergo oxidation reaction. Okay, metal gives rise to Mn2 plus electrons. So now oxygen, it will gain electrons, okay, converts into, it will reduce to oxide ion. So this metal ion, this oxide ion reacting both and forming a metal oxide, M2ON, metal oxide on the surface of the metal. Remember?
Ma'am.
You are remembering? Metal ion, okay, and oxide ion, both it will react together and forming a metal oxide layer on the surface of the metal. So that you have to explain here with the diagram. Okay. Hello, students. Okay, na? You are not there? Hello. Hello, students.
Yes, ma'am.
Mechanism
Yes,
of oxidation corrosion, you have to explain with the diagram. Okay.
Yes, ma'am.
How many types of layers are there? Tell me. Metal oxide layers. How many types are there? 4 types are there, students. Forgot, huh?
Yes, ma'am. 4 types.
Stable,
Stable, unstable,
unstable,
volatile, and porous.
volatile,
Porous.
porous. 4 types of layers are there. Metal oxide layers. After that only we will write about Pilling Bedworth rule. No? Yes or no? Hello.
Yes, ma'am.
Okay. So you have to explain clearly, ma. Nothing but here you have to explain dry corrosion. But in dry corrosion, 3 types are there. But here you have to explain about 1 type, corrosion by oxidation. Oxidation corrosion only you have to explain with the diagram. Next, 12th question. Explain the rusting of iron with the help of electrochemical theory of corrosion. So electrochemical corrosion you have to explain here. How many types are there, ma? Wet corrosion. Students, how many types are there? 2 types are 2 types. Okay, tell me 2 types. Hydrogen evolution, hydrogen evolution, type corrosion, absorption of oxygen type corrosion. You have to explain with the diagram here. Okay, and you have to write the reactions also. Okay, now corrosion, define corrosion, explain dry corrosion. So that you have to explain neatly with mechanism. What is electrochemical corrosion? Describe the mechanism of electrochemical corrosion by hydrogen evolution and oxygen absorption. See, questions you are getting differently, but you can write the answers. Okay, this is the wet corrosion you have to write. Students, what is electrochemical corrosion? What is electrochemical corrosion? When metal is exposed to the moisture conditions, on the surface of the metal, there will be formation of anodic area and
Cathodic.
hello. There will be formation of anodic area and hello
Cathodic
students,
area.
tell me cathodic area. So there will be formation of electrochemical cell, nothing but on the surface of the metal, some part of the metal becomes anode, some part of the metal becomes cathode. So which part of the metal is anode? That part oxidation takes place. The other part of the metal, cathode, that part of the metal, it will their reduction reaction takes place. So next class we'll discuss. Okay, now remaining questions. Hello students. We'll discuss in next class.
Yes, ma'am.
Ma'am.
Okay, I will leave the class. Any doubts tomorrow you can ask me. Okay, na?
Okay, ma'am.
Yes, ma'am.